right? Some noisy. Okay, thank you. Okay, I see. Okay, thank you for coming. My name is Tomohiro Fukuda from Osaka University, Japan. So in this paper, I'm a second author of this paper. Why? Because my first author, Sayuri Shimizu, is already graduated last month. So she started working from April 1st. April 1st is not fake. Then, instead of her, I have to introduce our research fruit. So, go back to my research topic, is a nighttime outdoor lighting environment design system using a web-based mixed reality to reduce light pollution. Let's start. So, here's the contents. Background. So, as you may know, the emergence of LED light emitting diode has led to the deployment of various lighting in outdoor urban spaces. However, excessive artificial lighting has led to the occurrence of light pollution. Is one of the factors contribution to the environmental degradations. So special consideration needs to be given to the placement of direct lighting, especially LED vision. So our target is consideration should be given to LED vision during the design phase to reduce light pollution in outdoor spaces. So let me try to, our target is roughly is a simulation models into mixed reality environment. So to consider direct light, necessary to understand the state of design luminance, including the surrounding landscape through light simulations. As you may know, the technology of overlaying the virtual models with real-world spaces in real time with full-scale mixed reality ML is available. So this figure shows the original ML definitions by Milgram and Kishino in 1994. So mixed reality is different from the virtual reality. Is by combining with virtual models in the real world in situ. So using these technologies and concept, it's possible to overlay 3D models onto existing real world buildings and lighting environment in actual size with full scale, enabling design considerations to be made. Also, web-based mixed reality that can be executed directly in web browsers has been developed. I remember that 2 years ago in Canada 2022, we developed a web-based mixed reality environment for lighting design and simulation for digital heritage. So this web ML enables landscape simulation for outdoor spaces using mobile devices like a smartphone or tablet. In virtual simulations of lighting environments, the visualization of lighting conditions using false color has been achieved for indoor spaces. Because this kind of display cannot display the real luminance intensities because they use control the intensity of the light. So false color is very convenient to check the lighting engineering aspect. So our objective is to develop a lighting environmental design system for nighttime outdoor spaces targeting LED displays, utilizing mixed reality to simulate light and understand the impact of luminance. So our contribution is there. So I think the audience will know the architectural and environmental aspect, but please share some technical term in lighting engineering issues. So in this terms, luminance is focused on the red colored, and we can see the light source like in these rooms. So the luminous flux amount of light that unit is lumen, And also luminous intensity, that means light intensity. That unit is candela. Then luminance, our target is luminous intensity per unit areas. Then the unit is candela per square meters. And then very popular factors, illuminance is brightness of irradiated surface on the disk, for example. So LED display is direct light, so we have to focus on the luminance as a target index. So let me introduce our proposed systems. So in the pre-processing process, the LED vision model and parameters are created and placed by game engine. And second, obtaining the sound images and camera information from the client mobile devices. So we are developed the server and client systems. So user use the web browser on the client. Then sending the acquired camera information to the server and overlaying it with the pre-processing models. And on the server, simulate rendering 3D models based on the estimated MR virtual cameras, and also using the LED vision 3D model and some parameters, and also rendering the full scale images based on the illuminance data. So then composition with these camera images sent back to the client as a live streaming, not the 3D models. That becomes a server engaged in high performance simulation and rendering roles, and then client is even the lightweight processing that can be realized with MR processing. So in detail, pre-processing in the game engine, creating a model and LED displays. So we can set this kind of LED vision of the 3D model like in detail. Each unit emits light. So this is an example of the LED pitch. We can change the pitch if necessary. And also in the game engine, creating the configuration parameters for adjusting the luminance and color of the LED screen models. And on the client side, this kind of remote controller was also designed. So user can change the luminance and LED pitch and false color, lookup tables, and also original colors of the LED visions. So we set the background area of the models in the game engine to green. That is natural, doesn't overlap with the 3D model, so easy to like the transparency rendering, like a chroma key effect. So, so we set lookup table, LED color is that color transformation scale used for color grading. So in this case, the false color conversion lookup table from the 0 candela per square meter set pure blue, and middle intensity 2500 candela per square meter set as a pure green, and the maximum intensity illuminance set as a red, pure red. Then false color indicate like that. So the verification test. So we set 2 verification tests in this study. So the first verification, we conducted accuracy verification of the lookup table. So as a ground truth data, we set the 3ds max Odesk by Odesk. This is ensure using the point writing simulation models as a writing analysis software. So as this, we set this is a ground truth, and this is our target. We developed the system using the game engine. We use the real engine file because this is very realistic rendering can be realized. So we set the same luminance values and then pick up each pixels and comparison with using these equations. So the result is a top area, top rows is a 3D Max result, and bottom area Unreal Engine 5, and red, green, blue channels, and this is each values and frequency. So after the equation result, the similarity of the RGB is very high level. One is exactly equal. So we check the LED is quite correct. And the second one is time is okay? Okay, 1 minute, okay. So we developed a new hardware LED vision with ESP microcontroller systems. So to verify, compare with the digital output and physical output. So this is evaluation output. The left side is a real LED vision that we took pictures, and then right side is a 3D LED vision output. So similarity is it's still very high values. So we confirm our proposed method is very good, but in detail, each set of the LED dot is very good result, but the surrounding of LED dot is not, sometimes is not same values as a hardware as one. And also this is MR operation verification like that. So using the current server systems, we have to check the latency of the whole systems. So actually 652 milliseconds has a latency from the input to output. So we show the conclusion remarks and also future works. Thank you for listening.
Professor Fukuda, thank you so much for this very clear, very good presentation. So any questions from the audience, please? I have a question, of course. I was wondering if the images from the different cameras from the mobile phones will have differences in the way that they capture the scene, and then when it is converted to the fade colors, does it make a difference which is based on the capability or the model or the camera of the phone itself? So have you, I don't know, I'm just asking you.
Yeah, thank you very much. Of course, one issue is how to calibrate issues. But in this study, we only focus on the how to realize, how to output the false color and the real colors for the design target. So the next step, as you said, I guess as you said, how to optical integrity is realized. But our investigation is already some how to integrate using the virtual model with a real nighttime scenes to ensure the optical integrity using the deep learning we found. So how to implement is next issues.
Yes, very good, thank you. Any other questions from the audience?
Yeah, thank you for your presentation. It seems that the main focus is indeed calibration. Now, I'm a bit puzzled. In the very beginning, you were speaking about LED pollution. So how fits this together?
I see. Thank you. In this study, we focus on the illuminance as a factor. But in fact, as you said, glare is more affect impact to evaluate. But as you said, glare is many formulas exist. So and also, so how to implement in the computational models? Of course, a model is proposed many formulas, but how to implement computational areas, and also next time is how to evaluate that system after realize after the represent false color of the glares. Yes, but we consider the next step.
But I meant to say, are you in favor or against LED pollution?
Oh, okay, okay. It depends on the intensity. So, okay, okay. We never see this kind of light, but LED display have to see because advertisement. And this kind of display is intensity already controlled. For example, 500 candle per square meters. But LED is some uncontrollable because due to the building owners and the designers. So it's already more than 6,000 candle per square meters. So if you can look at this, it's no problem. But sometimes in public space, unnecessarily I wanted to see, and so very comfortable or psychological aspects. So it should be controlled. So I think in Japan already has a kind of law to keep the landscape, good landscape for nighttime. Yeah.
Very clear, very clear. Thank you. Any other questions?
I was wondering about the use of this tool in real life. Like, let's say we want to test the impact of lighting, either on the users, or if the context is light pollution, maybe the subject might be animals as well. So how to deploy LED actually is going to impact animals and users, and maybe we can use mixed reality if we're actually implementing the technology while the user deploy, translate through the phone, and we can actually ask their feelings. I'm not sure about the animal part, but I think it's an interesting part when it comes to the light pollution as well.
Okay. Okay. As I said, as I explained, the much amount of the candle per square meters intensity is a very good back effect. So government would like to set some more political laws or some regulations, but it's just a number of the limited intensity. So designers and the building owners cannot understand well because there's no lighting designers. So people can, if using this kind of MR systems, so all the stakeholders gather on site, so set predicted future landscape. So should be discussed, can be discussed more intuitively, clearly, and also building consensus more smoothly. Yeah. So that's why, of course, BR is using the apart from the on-site building site. So it's more MR is more intuitive way. Yeah.
Thank you so much. I'm afraid I have to stop it here. If there are any other questions to discuss, please take it during the break. Let's thank our speaker again. And I invite the next speaker, Shamit Chatterjee or Rohit